Hey guys, so to continue our workshop, today we are gonna talk about monoids and functors in functional programming are uh, common patterns that we could use in several applications. So let me share my screen now. Can you see my screen now?
Yes, we can.
Yes.
Cool. So let's start with monoid. So informally, an monoid it's an abstraction over adding or combining operations. So in code, this is idea. We have two operations, an empty operation and a combined operation. That it says we have two different objects the same type, and the idea is combine and get
Giovanni,
one. Yeah.
we're seeing the code. I don't know if you're writing something. We're seeing the trait monoid. If
Oh,
this is what you intend to
yeah.
share.
Let me share. Oh yeah, was in the ground screen. Right now, it's there.
Ah, yes.
Oh, thank you. As I mentioned it, we have two operations over monoids: an empty operation and combined operation. So let's implement the skeleton for our type class. As you remember, the last session, I show what means type classes. It's on a functional uh, polymorphic way behavior using pure functional stuff. Just for remember. So I just add a definition for the zero operation. It's just to avoid boilerplate code. And as you remember, this is the type class, monoid type class. The idea is, as mentioned, provide a skeleton, and we will see an example to make sure that it's working as we expected. Right? If you have any question about syntax or whatever that you need to clarify, just let me know. So uh, it's just type plus implementation. This is the skeleton. So the idea is I'm gonna create other example. Can be on a simple one, and all the return object. So the idea is we're gonna kind of zoom of integers, and empty QB should be, I mean, and assume with geovalue, and the combine is just on a new zoom. This is just following the type class pattern. It's just created the full implementation for monoids over our type. So I created also some testing stuff, and the idea is proof that we are able to zoom our this graph, and we shouldn't have any kind of problem. It's on a simple zoom. Also, as an rules or properties that we have that monoids have is they provide an identity. So that means that you have any value and try to combine with the zero operation, you will have the your value. That means it's an non-annulator operation. Uh, Here you can see is associativity. That means you have three different type of monoids, and you combine in different order. Uh, the result should be the same. So let's run the code. Oh, this is for the other stuff. Let's commit for now. Also here. As you can see, our testing were successful. So at the moment, not very impressive over this stuff, but we want to talk about a little bit about the uh, usages for this stuff. So For instance, when we have on a big data application, probably many of our workers have to do a piece of operation, and then we have to find a way to combine the results and make sure that we are not to combine in a bad way. So it's pretty useful in that kind of scenarios. For instance, in Spark, we have Spark is on a kind of streaming processor or Scala and Python, I think. And the idea is there are a bunch of computations distributed over many computers. So the idea is split the data process independently and then try to combine using monoids could be, but I think it's implemented through uh, map. I forgot the concept, but the the key piece is full implementation is using a monoid as an implementation. Other usages is in any distributed system. It's pretty similar than Spark, but just for architectures over distributed space. So, for instance, we have many microservices, and we have to combine operations or send our message brokers, things like that. So this is pretty useful. It's an a concept that's an abstraction over the concept to adding or combining. So here we can be more creative and use put our uh, requirements or case uses here. So it is just for showing you the concept. Also, I left you this object. So the idea is you can complete the implementation for a monolith of list, and hopefully you will be able to run the test and make sure that it's working. So it's just for if you want to practice a little bit more. Any questions up to this moment?
Giovanni, can't you show the M0 definition?
Uh, for sure. Oh, here we go.
Ah, okay. It's the same as empty.
Yeah, it's just
Ah, okay.
for kind of syntactic sugar. Only instead of do this on a wrapper to write less
Ah,
code.
okay. Yeah, perfect. Thanks.
Cool. Also, I think I forgot to mention in Scala we can define function with that kind of symbols. This on a wrapper for combine. It's uh, it's just for make our code easier to read. Yeah. So let's talk now about functors. So a functor, in a pretty informal way, an a functor is anything with map method implementation. This is pretty informal. Let's talk about a little bit more for this. Scala already implements map method. We are trying to create the different one to make sure it's not the Scala implementation. So we have this. This is our function map transformation. So this is the idea. Let's try to read that signature. So the idea is we have this is this syntax. I mean, this is in a context in Scala, so it's on a generic, uh, pretty general. It's pretty weird to try to explain. Some examples could be a list for any type, or we have an optional in Scala is to model if we have a value or we don't, and other kind of stuff. So the idea is provide a generic context, whatever you want, and include the fmap operation. So the idea is try to represent a sequence of computation or transformations over this context. That means we have on a list, for instance, on a list context for on a type T. With fmap, move we will move to other type. It's another transformation within the context. Let's try to see in a better way. So let's continue implement the return this. I just implement this map just in order to uh, be able to use for comprehension. That means, in other words, as if you don't remember, is this syntax. Or and we have for pointer. That's it. Yeah, just going to write the same method just for be able to use this syntactic sugar for the language. Not much interesting here. So selecting other syntax. Uh, so this syntax is pretty similar than in monoid implementation. This is equivalent to do to include that part implicit uh, functor in this case, but is this is short. This is provide an implicit over uh, this context. That's the idea. It's other alternative to write. I'm gonna use both in case that you start taking a look, taking a look more Scala code. So you will find probably both, but it's essentially the same. So questions up to this moment?
Well, I haven't. Well, I'm not pretty clear. I'm not much clear on what's the point yet of monads and functors.
Cool. So think a little bit about uh, what in the current stuff you are not able to use any abstraction to combine computations. So that means you have to create isolated operations, but you don't have a kind of way to relate it, that operation. So for instance, we are gonna go into to database, got some data, but we need to transform. We uh, in oriented stuff, we are not able to use any abstraction for that. That's the idea here. Use that kind of abstraction to provide uh, safe context. That means context without uh, through all implementations or uh, have our context isolated to avoid side effects or that kind of situation. That response to your question, or we need
It
to keep.
it that, so it will be similar to in C and C++. You can override the plus and you can override the arithmetic operations in a single class. So the plus, the minus, the so that class A, if you override its plus function, then you can do class A plus class A equals something. So that, for
Probably,
example, you can override the addition.
yeah, just
It's
for
similar to that.
in terms of implementations, yeah, probably. So, but the idea is uh, start thinking over abstractions, uh, not using pure code or whatever that you have to do. So these definitions or abstractions provides you on a powerful tool. So for instance, humanoids. So we have already implemented for basic types, almost for numbers. You have that kind of well defined this, but what will happen is that could be on a product, on a product, and you want to combine in terms of business definitions. So the idea is don't reinvent the wheel. Uh, I'm not sure if I'm doing in a clear way. That's the idea. Just try to have skeletons and try to implement as we need. Always try to obey the laws for this. That could be that means if we implement a monoid whatever we want, now we have and idempotent operations, because it doesn't matter how we combine a monoid, we always got the same result. That kind of abstraction is the things that you gain or you achieve without do anything else. That's the, I'm trying to say to you. Much clearer? Cool.
Yeah, I think it's more clear. Johnny, you're providing the contract, let's say.
Exactly. I'm gonna try to put some real exercises to make sure that really could do real applications. So uh, let's retake functors, and the functors utility is the same. Just provide an context and try to compute on a sequence of computations without lost our context. That means if we have always the same context, you will be able to combine operations because it's the same. I mean, if we have an abstract context for any type and we do a map operation, we transform from type E to R and so on. So we don't lose our context, and we will be able to do any transformation that we want. Also, we have to make sure that this computation is safe. Probably in the next session, I will try to deep a little bit more. But if we have, for instance, other contexts with other type, we can combine without do anything else. We can start doing sequence of these computations without do anything else. That's the idea behind that. Provide always on a context. This context could have any operation and try to combine them to get the result that we need, whatever be the case. So for instance here, pretty simple examples. So the idea is just include an assume for this, and also we have identities. So this is implemented for Scala, but is just an wrapper for the same uh, implementation. So the identity function is the function that returns the same, that kind of thing. So for instance, this composition stuff, so we have two functions, f and g, and we add one in a first function, and then we move to an string stuff. So that kind of things we can start to doing the sequence of any computation that we have. So this could be in a real scenario, that could be an call an API and then to do anything that we need, that kind of things. So in the other session, the idea is see how we can manage errors or things that we can happen in our stuff. So let's run the testing stuff. It's not working. Oh, yeah. I will check the code quality. Have some issues with the ID, but yeah. So I think could be really at work at this moment because it's thinking a little bit different. That I will try to show you real examples in the repo. That the idea is you try to practice a little bit if you have some time. And yeah, that's all for now. I don't know any other question or things that I can explain you in a better way.
No, Giovanni, I think we need to play a little with the repo.
Yes.
Not
Yes.
understand
Thank
better.
you.
Cool.
Yes, thank you. Thank you very much.
Thank you.
For sure. Anytime. Thanks, guys.
Thank you. Bye.
Bye. Take care.
Bye bye. Yes.